Welcome back to West Explains Best. Today we're going to be covering notes in section 8.3, equations, quadratic, and form. Let's go ahead and get started. We did something similar to this when we covered rational equations, but this time we're going to have some quadratics that we're going to have to deal with after we get the denominators out of the equation. So what I'm looking at here is I see 1 over x plus 1 over x minus 1 equals 7 over 12. I always want to get rid of all the denominators. In order to do that, I multiply all the denominators to cancel them out. So I need to multiply each term, distribute each term, and this will eventually cancel all my denominators. I'll show you in just a second. First thing I'm going to do is I'm going to multiply, and I'll show you. I do 1 times all this, and I just get that. I do 1 times that, and I just get 1 times, and, oh, sorry, we get 12x times x minus 1 over x minus 1, and then we have 7 times 12 times x minus 1. This one's a little bit more challenging, over 12. Okay, now what I like to do is I like to cancel. I got some feedback saying that they like to have me show the numerators first and then cancel once I show all the numerators. So that's what I'm going to do here. I'm canceling what we see in the top and the bottom, and now we can write it. I need to distribute this 12x to both terms, so I get 12x minus 12 plus 12 times x is just 12x, and then I have 7 times x minus 1. This is where the quadratic in nature comes in, so I can change this 7 times x to just 7x. And now I'm multiplying this 7x times x minus 1. I get 7x squared minus 7x. And then I have 12x plus 12x. This gives me 24x minus 12. My x squared is already on the right side, so I'm going to move everything over. So minus 24x plus 12 minus 24x. I'll move this guy over, actually. Put him by his buddy. And then plus 12. What do I end up with? I end up with 7x squared equals 0. 7x squared minus 31x plus 12. Okay, now I have some work to do. I am going to factor this, and I think it can be factored. But we'll take a look to see if that is true. So what I'm going to do here, I put 2 parentheses down. And I'm going to think of my factors of 7x squared, and I'll put those in the first slot. And then I want to think of my factors of 12, and I'll put those in the second slot. Factors of 7x squared are 7x and x. Those are the only factors, so I go ahead and write those in. Now with 12, we need to be a little bit more cautious because there's 4 and 3, there's 6 and 2, there's 12 and 1. I also know that they need to be negative because my middle term is negative. See that my middle term is negative? So that means I need to make all these negative. Negative times negative also gives me a positive 12, so these are negative. Now I think, okay, 7 times which of these factors would get me close to negative 31x? Well, I know 7 times 12 is going to be way too big, but 7 times 1 is going to be too small. So I think these ones are out. We can pretty much eliminate these ones. 7 times 6 is going to be 42. That's a little too big, but it's not out of the realm of possibility. But look at this. 7 times 4 is 28. That is very close, so I'm going to roll with this one. So instead, I'm going to do 7, and I know that this 7x is going to be multiplied by the outside terms. So these two terms are going to get multiplied together, and these inside terms are going to multiply together to give me my, and it can combine to give me my middle term there. So I know it needs to be a negative 4 and a negative 3. Why? Well, I do negative 3 times x gives me negative 3x, and then I have 7x times negative 4 gives me negative 28x. Those combine to give me negative 31x. So there I have it. I have 7x minus 3 equals x minus 4. We're not done yet. We know that each of these, let me copy and paste this. Give me a second. I think I got it. About to find out. Close enough. Okay, so we know that both of these need to be equal to 0. So this needs to be 7x minus 3 equals 0. That's called the zero product property. So then I know 7x must be equal to 3 divided by 7 divided by 7. I get x equals 3 over 7. That's one of my answers. Check with, oh my gosh, we forgot to do this. Check answers at the end to see if they fit in the domain. Well, what are we doing here? We need to check our x. This cannot be equal to 0 in the bottom. So x cannot be equal to 0, and then x minus 1 cannot be equal to 0, so x can't be equal to 1. So we need to make sure that we don't get 0 and 1. 3 over 7 is not 0. That's good for an answer. Same thing with x minus 4. This needs to be, is that equal to 0? X minus 4 equals 0. Add 4, add 4. I get x equals 4. So there's my two answers. I get 4 and 3 over 7. Moving on, a riverboat for a tourist averages 12 miles per hour in still water. It takes the boat 1 hour, 4 minutes to travel 6 miles upstream and return. Find the rate of the current. So I have a 4-step process to try to get this done. One, you're going to read the problem. We have 12 miles per hour in still water. That's without the current. So we're going to be using that. That, by the way, is a rate. Miles per hour. Anytime you see a per, that is a rate. Per hour, per kilometer, per minute. Okay, those are all rates. It takes about 1 hour. Okay, this is our time. This is total time. So we have total time given here to travel 6 miles. Now we have more units. 6 miles upstream and return. Okay, that means 6 miles up, 6 miles back. So 6 miles upstream and 6 miles downstream. Find the rate of the current. Well, we have this useful little table here along with some of our formulas. We know that rate is equal to distance divided by time. Okay, miles per hour. That's a rate. If we arrange this a little bit, we can say that time is equal to the distance divided by the rate. Right now we're trying to find the rate, so we need to do step number 2, assign a variable. So we want to know the rate of the current, so we're going to say x equals the rate of current. Okay, now let's think about this logically. If we have a current here, and it's moving this way, and we have our boat, okay, look at our beautiful boat here, and it's going this way, what do we do with those two rates, with the rate of the current and the speed of the boat? We would add those two together. Now, let's think about the opposite scenario. We have our lovely river here, and this is the current, but now we have our boat, and it's going upstream. So this was downstream. This is upstream. What happens? Well, we're going to subtract. Okay? They fight each other, so they're going to subtract. We have the difference of their rates. So we can go ahead and insert some information. So the distance, we already determined the distance. That was one of the first things we saw. We know it's 6 miles upstream and 6 miles downstream. Now with the rate, this helps us with our rate. We already know that the base is 12. The boat by itself goes 12. I don't want to use green, it won't show up. Let me just keep using this pink. So we know that the rate of the boat goes 12. Now, when we go upstream, we subtract the rate of the current. We know x is the rate of the current. We assigned a variable. That's what we're looking for. So we subtract x. That means we're going to go slower. When we're going downstream, we add. We add the rate of the current. So we add x, and then because we're going faster. Now, the reason why we set these two boxes up is because it helps us form our last box, time, because we are given the total time. Because we're given the total time, we need to set up an equation in terms of time. So what is that? Well, we know that distance divided by the rate is equal to time. So we can do our distance divided by our rate. That's the time for upstream. The distance divided by our rate, and that's the time for upstream. We know that the total time was 1 hour and 4 minutes. But here's the problem. When you're talking about reading, this first step, we notice that we have hours and minutes. It should all be 1. So we could do a couple different things here. We could convert this to minutes first. We have 64 minutes. And we know that there's 60 minutes in an hour. So we're going to divide that by 60. We can reduce this fraction, and when we reduce it, we end up getting 16 over 15 because we divide each by 4. So that's our total time. Now, sorry, I kind of went on a little sidetrack here. What was I saying? Well, I was saying that our time upstream, 6 over 12, excuse my pencil here a second, 6 over 12 minus x, plus our time downstream, 6 over 12 plus x, needs to be equal to our total time, which we determined was 16 over 15 hours. Now, the reason why I converted to hours is because these are already in 12 miles per hour. If you wanted to convert 12 miles per hour to miles per minute and then use minutes, you could do that. Okay, so you could calculate that, but you need to have everything in the same units, even the rates. So because it was already in per hour, I decided to keep this time, the total time, in hours. So 16 over 15 instead of 64 minutes. Now what do I do here? Well, this is one of our, let me shrink wrap this real quick, get this out of our way. Pause it, zoom in, whatever you need if you want to see that again. Well, we need to get rid of all these fractions. So let's zoom in and take on this problem. This is just like our example in the first one. So I'm going to multiply everything by 15 times 12 minus x times 12 plus x. And I'm going to distribute this to all three. Okay, let's go ahead and show that. So I have 6 times 15 times 12 minus x times 12 plus x. Okay, I essentially have the same, over 12 minus x, sorry, 12 minus x. I essentially have the same thing going on in the second one. Copy, paste. I need a plus sign in between, but now it's going to be over 12 minus x. And then I have, I'm not sure where the keyboard popped up. Did not ask for that. Okay, that didn't work. Let's move this over a little bit more. And now this is equal to 16 times 15. Whoops. Times 15 times 12 minus x times 12 plus x. I'm just trying to get rid of the common denominators here, or the denominators. That was an ugly line, but you guys get what I'm saying. Okay, now the long and short of it is, as I change positions here, the long and short of it is, we did this so we can cancel. We did cancel this, cancel that, cancel this. Oops, this was supposed to be 12 plus x, wasn't it? Sorry. Cancel this with 12 plus x, and then 15 with 15. And we're going to multiply whatever's left over. So we do 6 times 15, I believe that's 90. So we have 90 times 12 plus x. We have 90 times 12 minus x. And then we have 16 times 12 minus x times 12 plus x. Okay, now it's just a matter of simplifying. We have a really big problem here, but we can do just fine. We're going to do 90 times 12, and that gives us 1080. So we have 1080 plus 90x plus 1080 after I distribute. That's what I'm doing here, distribute. Plus minus 90x equals. And by the way, if you don't want to see all this, you guys can fast forward and make your lives a little bit easier instead of watching this. This could get a little tedious, as math often does. 192 times 16 minus x times 12 plus x. So you can FOIL this. Honestly, what I would do first, I wouldn't do what I just did. I would have distributed this first, and since this is difference of squares, you get 144 minus x squared, and then you multiply that by 16. So we get 16 times 144. 16 times 144. That gives me 2,304 minus 16x squared. And now I have, let me combine 1080 plus 1080. 1080 times 2. We get 2160. 2160 plus, we have a 90x and then minus a 90x. Those are going to cancel. So we're almost done with this problem. Rewritten over here, let's go a little bit to the right. We have 2160 equals 2,304 minus 16x squared. So we need to get everything over to one side. I'm going to move everything away from the 16x squared. So I'm going to subtract 2304 from both sides, minus 2304 from both sides. 2160 minus 2304. Okay, and then divide by negative 16. Sorry, I didn't write out my answer. 144, negative 144 equals negative 16x squared. I divide by negative 16, and I get negative positive 9 equals x squared. So then I get plus or minus 3 equals x. Now we need to consider this in the rate of the problem. You wouldn't have a current rate of negative 3 and then also a positive 3. So we got to pick one. We can't have just one current. So let's go with a current rate of 3. I think that makes a little bit more sense that we just say it's 3 miles per hour instead of negative 3 miles per hour. Okay. So we have the current is 3 miles per hour. Okay, we're going to take a quick recess before we get into these last 3 problems. So go ahead and get some water, come back. Hopefully you guys haven't been watching this the whole time. For the next time, maybe fast forward, pause, copy down some notes. If you need an explanation, great. But most of these problems are pretty similar in this regard. This next example is probably the toughest and the other ones are okay. So I'll see you soon.